Hello, everybody. Today we're going through phase change graphs for water, specifically heating graphs. In our ILO for today, I can analyze a phase change temperature graph and determine at what temperature phase changes occur. Let's take a look at our graph. You should have received a paper copy already, so you can go ahead and write in what you need to as we go along. As we first take a look at our phase change graph, this is again the heating curve for water. And we're going to go from solid to liquid to gas. You'll notice along the x-axis we have time in minutes, and along the y-axis we have the temperature in degrees Celsius. So before we start the clock, we are at negative 20 degrees Celsius. And then we take the temperature every minute going along as we go. Starting off with something to remember about this graph. When we're talking about a heating curve for water, we're going from a solid to a liquid to a gas. That is endothermic. Heat is being absorbed by the water. So when we start as a solid, heat is absorbed, it turns to a liquid, heat is absorbed, it turns to a gas. That's endothermic. Think endo into, heat is going into the ice and the water. We're going to start down bottom here at number 1. Go ahead and color yours in blue by the number 1 there. That's going from negative 20 degrees when we start, and 2 minutes later, it's up to 0 degrees Celsius. Phase 1, we're starting as a solid. At this point, we're talking about ice, so it is a solid. You'll notice next, from the 2-minute mark to the 5-minute mark, the temperature doesn't change. That's where it's green. Feel free to shade in that part of the line green. That's number 2. In our chart number 2, that is where the ice is melting. Notice, as the ice is melting, the temperature doesn't change. We are still adding energy, adding kinetic energy, but now this extra energy this energy that we're adding, it's required to change it from a solid to a liquid. So we don't see a temperature change. The temperature does not change as we're in the phase change. This is the heat of fusion. That is the energy required to change a solid to a liquid. And during the phase change, the temperature doesn't change. From 2 minutes to 5 minutes, the temperature is still 0 degrees Celsius. Again, that's the heat of fusion, the energy required to change a solid to a liquid. From 5 minutes all the way up to 13 minutes, the temperature continues to increase. Now we could color that part in yellow. That will be your number 3. So from 5 minutes to 13 minutes, that ice is now gone through the phase change. It is all water, but it continues to heat. The temperature continues to go up until at 13 minutes, you'll see it reaches 100 degrees Celsius. From 13 minutes to 16 minutes, you'll notice again the temperature doesn't change. This we'll label as number 4. And it remained water all the way up to 100 degrees Celsius. This plateau is another phase change, so we're going from water to a gas. It is now vaporizing. And at 100 degrees Celsius, the water has reached the boiling point. It begins to vaporize. The temperature we still apply, we're still adding energy, but we don't see a temperature change. That's because that energy is required to change it from a liquid to a gas. That is the heat of vaporization. It's the energy required to change a liquid to a gas. So when we're at this stage, this phase change, the temperature does not change. Finally, at the 16-minute mark, as it's gone through the phase change, we now have number 5. We can color this red. And this is a water vapor now. It's in its gaseous state. It is water vapor. So we've gone from ice at number 1, melting number 2, where the temperature isn't changing, going from ice to water. That's the heat of fusion. Number 3 will color yellow. That is water. It's liquid. Number 4, color orange. That is the heat of vaporization. We are now vaporizing, and where the temperature remains the same during the phase change, that's the heat of vaporization. And finally, number 5, that's where our water vapor is now in its gaseous form. And that, ladies and gentlemen, is a phase change graph for water, specifically for heating. Feel free to go back and review this video. You can pause it as you're doing your paper copy. I also have a copy, the Google Drive, Google Doc copy for you. If you wanted to work on that, make your own copy, submit it to me that way. But tomorrow I will be checking your paper copies as well. And as always, you'll have that paper copy to study from then. Guys, thank you for your attention. You'll notice you had your spot earlier. Once you finish your graph, you can go on to your exit ticket and the practice. Have a great day.